Welcome to our second lesson of our fourth unit, trigonometry, in our grade 11 University College math class. Today we're going to be doing the lesson applying the primary trig ratios extra practice. So basically this is sort of a primer on how to find side lengths using primary trig ratios, depending on where the missing side length shows up in our ratio. And we're also going to figure out how to find an angle given the two sides of a right angle triangle. Let's just jump right in. So in this first scenario, what you'll notice is that the variable that we're trying to find is in the numerator. I would like to remind you that tan 72 degrees is an actual number. Now I don't want you to figure out what that number is at this moment. Let's use algebra to move tan 72 degrees around, and at the very end we'll actually calculate what tan 72 is. So because tan 72 degrees is a number, we can just as easily put it over 1, and all of a sudden we have this nice proportion set up where we have this fraction on the left and a fraction on the right. That's a ratio on each side, and that's called a proportion. So for us to clear this proportion, which means really just to sort of get rid of the fact that there's a denominator, I'm going to recommend that we cross multiply. So when we cross multiply, we have y times 1, which gives us y, and then we have 6.1 times the tangent of 72 degrees. What's nice about having the unknown variable in the numerator is that from here it's really just one calculation. So I'm going to type that into my calculator now, 7.1 times the tangent of 72 degrees, and that's going to equal 18.8. Whatever the units happen to be. So again, make sure that you're getting this correct answer out of your calculator when you're working it through. If you're struggling, maybe you want to check that your calculator is in degrees as opposed to radians or gradians. If you're having trouble outside of that, if you're sure your calculator is in degrees, it might be the way you're typing it into your calculator. For example, on the calculator that I'm using, I can type this line here exactly as I see it. I can type in 6.1 times tangent of 72 degrees. Some calculators will require you to type in 6.1 times 72 tan equals, and that should get you your 18.8 units. Hopefully that helps you out. Let's have a look at the second example. It's a little bit more work in the second one. So the sine of 58 degrees equals 18.8 over x. So what we're going to notice is that this time the variable we want to find is in the denominator. Still okay, we're going to approach this in the same way. Sine 58 degrees, of course, is a number. We're not going to calculate it, but it's a number. And we can clear the two fractions in this proportion by, again, cross-multiplying. So let's do that now. We have x times sine of 58 degrees, and that's equal to 18.8 times 1. So we'll just leave that as 18.8. So now we have an equation where we've got x being multiplied by sine of 58 degrees. In order to isolate x, we need to divide both sides by sine of 58 degrees. And again, that's a number. It's not just 58, it is sine 58 degrees. That's a number. And then we have x is equal to, and now we can type this right side of the equation into our calculator, 18.8 divided by sine of 58 degrees, and that's going to equal 22.2 units. So this is the two different ways that you can figure out missing side lengths in right angle triangles. The first, where your numerator has the variable you're looking for. The second, where the denominator has the variable that you're looking for. The only thing that remains in this three variable equation is to solve for the angle. And this is the part that's a little bit new. I think for some people they find this challenging. So let's have a look at this. So we have the cosine of angle C equals 7.9 over 13.5. So what we have is a completed ratio on the right. It's on the left where we want to isolate angle C. So the opposite operation of taking the cosine of something is to take the inverse cosine of something. Now on your calculator, I'm just going to write this out. So if we want to find angle C, we want to do the inverse cosine of this completed ratio here. Now, where this is on your calculator is typically the second function or the shift of your actual cosine button. So if you find the cosine button on your calculator, typically if you hit second function cos or shift cos, that's where you'll end up with the cos -1. So again, on my calculator, what I normally type in is second function cos. So in my display, I can see this, the cos -1. And now I'm going to open up a bracket and type in 7.9 divided by 13.5. And I'm going to close my bracket and hit equals. And that's going to give me angle C, whoops, that's a highlighter, angle C being equal to approximately 54 degrees. So when we're talking about just trigonometry in general, we're going to be rounding angles to the nearest whole degree, so 54 degrees, and we're going to round side lengths to 1 decimal place, typically. Again, hopefully you're able to get this type of number out of your calculator. That's my goal. There is some homework attached to this short lesson. It really is just to get you going over the mechanics of how to find missing side lengths in either the numerator or the denominator, and it also goes over how to find a reference angle if you're given the two sides that make up your primary trig ratio. Hopefully this is all good. If you have any questions, as always, feel free to email me. Otherwise, good luck with your homework, and we'll see you in lesson number 3.